Hey there, Math 125 fans. Let's talk about integration techniques in general, and then I'll break out and actually do a few examples of each. Again, I'm not trying to reteach the entire thing, but want to give you a snapshot of where we're at. Those are all questions from my spring 2016 and winter 2015 exams. I tried to pick a couple older exams that I haven't already made videos for. Those are the integrals that are on the first 3 pages of each of those exams. I think I have 2 per page. We need to be at a point where we see those and we have lots of ideas of how to start. So if you're not there yet, I have when I'm teaching the course, every day that I have class or quiz section, we have problems on the board when students come in. None of those should scare you. So you might think about which ones scare you, which ones do you not know how to start. That's really a key to success on exam 2 and the final in this course, because if you're going to move forward, you have to be good with integration. So let me say a few things, and then we'll just talk about those, and that's all I'm going to do in this video. And then I really want you to think about what is your first step. Let's break it down further. If you were to open the exam and you saw that question, what's the very first thing you're going to write down? And if you have practiced and you follow my advice I'm about to give you, you should never stare at an integral. You should immediately start working. So sometimes during a test, I'll wander around and there'll be a student just staring at an integral. We can immediately work. We have stuff we can always do. You just have to go. Okay, so I'll explain what I mean by that. But before we do, let's recap a few things. Here's my materials page again. At this point, part of the reason you did all that work, all that integration, was so that these 4 techniques became more routine. We have this integration by parts, which is really good for products, logs, and inverse trig. So if we see logs or inverse trig, that's jumping out at us. We have a method that's good for products of sines and cosines. It's a very particular method. It's basically substitution. The only time it's not substitution, it's if sine and cosine are both have an even power, and then you just bang it over the head with the half angle identity until the answer pops out. So those are very specific. It's usually not hard to tell if it's a combination of sines and cosines, because it is. Trig substitution is extremely specific. Typically when you have a square root and you have a quadratic under it. So those are pretty easy to tell. Partial fractions also are very specific. A rational function, a polynomial over a polynomial. So to me, these 3 methods, you never have to look at for more than an instant, and you know if it's one of those methods, or you know if one of those methods is reasonable. So what are the challenging situations? The challenging situations are when nothing jumps out at you. And in those situations, what do? And you do simplification or substitution. So to me, it becomes really clear. Now, are there unusual cases? Yes. Are there unusual cases that happen in our courses? No. This is not like an integration challenge at MIT or something. On these exams, all these questions are made to be done. So it's not some quirky thing you have to look on a YouTube video to figure out, even though you're watching one right now. Okay, so again, if you need a more thorough review of those things, which often happens, I have that stuff. Probably your best resource would be to go to my old lecture notes, because then you could see me breaking it down. You'd have to read, which I know no one does anymore. But I have examples like trig integrals. What do? And if you really go through my notes, you'll realize in the end I say, forget all those techniques. Here's how you attack these sorts of problems. So I have examples. It's a good way to go. And I have more videos and things. But let's circle back. Okay. Is anything there look like a product, a log, or an inverse trig? There's an inverse trig. Okay, this is by parts. Is there anywhere where there's a product, a log, or an inverse trig? Right here, there's a log. Maybe we will end up doing by parts. Now, that doesn't mean that's absolutely what you're going to do, but that's the advice I give students. And the moment you know it's by parts, you can write this out. So there is no reason on either one of these 2 questions to sit still. or to be staring. And if you know how by parts works, you basically have to make one decision, and then the rest of the problem, you just turn the crank. You just go. And that one decision is simple. So you can see in my notes, I talk about how you don't even have to turn your brain on. You can just immediately say, I put the log thing here. I put the inverse trig thing here. And then everything else we fill in. But I'll leave that for the next video. Okay, so all right, those were the ones that were obviously integration by parts. Products, logs, inverse trig. Okay, now somebody might say, well, this is a product, but that looks like something else. So which ones look like trig integrals? These ones. This jumps out at you. I do a lot of this in class. We know how to do those two. You might say, well, I don't know how to do those two. Well, that's a certain question. You put a note on that and say, that's something I need to study. I can go back and study that. Here I have an odd power, and here I have, so the only time you're using the half angle identities is if all the powers are even in sine and cosine. So we're going to set up a substitution. I do a lot of this with my students. I say, what's the first step? We have a page where that's all we do. And the first step here is to pull out a sine and change everything else to cosine. And if you can do that, then substitution will work. That's the point. We're setting up a substitution. And the nice thing about when you remove 1 from an odd number is you have an even number. That's the entire premise of the whole section. I think people get lost in all these step by step, but here's a sine squared here, but you can write it as 1 minus cosine squared. And now we're perfectly set up for a substitution. So if you're having to look in a table or look in a note sheet to figure that out, it's taking too long and you're not really understanding how it's going. Same thing here. It's going to be a substitution. And if I didn't have a note sheet, I would say, well, there's only 2 possible substitutions I'm going to try. I'm either going to try secant of 2x or I'm going to try tangent of 2x. And you could just try both. But we do talk in the section about which one might work better. If you take the derivative of this, you get this. So in these problems, you're thinking about not only what you're substituting in, but the derivative that needs to appear. And in this case, I have an even number here, so I could pull out 2 secants and make this appear. And again, I'm not going to do the whole thing. Or I could pull out, and this one actually, let me think about it, I think works both ways. So this is a problem where either one would work. Okay, so we've already chunked off a few things. All right, do any of those look like trig substitution? This one, this one. Ooh, I almost did that one, but this doesn't look like trig substitution to me. These ones both have a square root and an x squared underneath. And so I'm immediately going to start that technique. And if you've prepared, you know what goes here. You know that this is 3 tangent of theta. And then you have to deal with the consequences of this. The whole reason you do that is because the square root goes away. This one you should know you have to complete the square and then do the appropriate trig sub. So we're just chunking it off. So when I look at that, you step back now and you say, well, and I missed one more. There's the other one I was trying to look for. There's a quadratic and there's a square root. And you'd complete the square. And you can see on both my exams, I had something where you had to complete the square. It's something you got to deal with, but I'll talk about that in a separate piece. Then we have partial fractions, a polynomial over a polynomial. Here, here. Both of those, you're going to factor the denominator, and then you're off to the races. So again, there's no reason to be still here. This is what you've been practicing. So I know I'm saying a lot of stuff, but by the time you roll into that exam, you'll have done many weeks of homework. You'll have done worksheets. You just have to know the start. And here you need to know the first step is to write a over x plus b over x squared plus c over 2 minus x, and then solve for a, b, and c. So that's the point I want to make. You don't have to look at an integral for a long time. You need to know, is it a product, log, or inverse trig? We took care of those right away. Was it a trig? We can see those. Was it a trig substitution? We saw those. Was it a partial fraction? So when that's all said and done, you have these two things that did not jump out at me. And that goes to my process. So if it's not one of the methods that we immediately know, then it's simplification or substitution. That's how I approach every problem. It works very well. I've rarely encountered something in my 20 years of doing Math 125 where the approach I just gave you didn't work. Okay, so I don't see how I can simplify this, so I'm going to do a substitution. To me, the only substitution that makes sense, and I often tell the students, if I'm doing a substitution, I kind of don't know where it's going. I like to use a t instead of a u. That's a personal preference. I like to save t for later. But I would probably do 1/4 t to the 1/2. Sometimes students say, well, how do you know to include the 1/4? I don't. It also works if you don't include the 1/4. To me, it's just, you can't be idle. I mean, what are you going to pick? You're either going to pick this, or you're going to pick all the stuff in here, or you're going to pick everything. There's like only 3 choices, and you've ruled everything else out. So after you've kind of thought about it this way, you're like, there is no reason to be still here. I know I have to do substitution. You're driven. I think the problem is students are worried that they can't see their way to the end of the problem, and I understand that, but that is not a reason. That fear is not a reason to sit and do nothing. Okay, there is a little maneuver here, which is I could have moved the 4 to the other side and then square both sides. That's something we talk about, called a rationalizing substitution, because that just makes things easier, like to take the derivatives and everything. But I'll leave that for another video. It's going to simplify. When you're done simplifying, you take the derivative. I think then you get a product, and then it's by parts. But I'm not worried about that right now. Same thing here. What am I going to do? I don't know if I should pick this. I don't know if I should pick this. They both work, I know, because I've done some of these problems. It might even work to pick the entire thing. I've actually done this with students before where they're like, I don't know what substitution to pick. And so in office hours, I'll do all 3. And I've been surprised how often that all 3 work. Now, this is a weird choice. So if that works in some way, I'll be really surprised. I think it might be better to choose the entire denominator, but I don't know. If you choose this one, you might have to do an extra step later. They all work. So this is the point I make to my classes, is there's no reason to sit still. Okay. There's no reason to leave a problem blank. It's painful when I'm grading and the student has left one of these problems blank, because we know what score that gets. I get in trouble if I don't give that a 0. Okay, so that's my little soapbox, but this is t. I can replace the square root with t minus 3. I can take the derivative of this. dt is dx. Oh, I'm going too far here. Is that the fastest way? I don't know. I made a YouTube video a while back about integrating. Somebody asked me this hard integral, and I did exactly this and got the answer. And it was funny because somebody posted, oh, this guy's doing it in a dumb way. There's a faster way using some identity. And I was like, I replied and said, you're under the impression that I'm smart. I'm not smart, but I do have a method that will solve all these problems. And the next day, that person subscribed to my channel. Success. So you don't have to be clever to do math. You need to have an organized process and plan. So I hope that helped. So next I will do a little snippet on each method. I mean, I can't go in detail, but I think that the process is what I'm trying to sell you on. And I have plenty of other videos where I do stuff like this. If you look through my old exams, I think everyone can do integration. There's going to be little bits of spots where you might get stuck, but I hope that gives you a plan. Okay.